Hello everybody. Here's a problem I found on my math lab assignment, and it goes like this. It says that there's this function called capital G, not to be confused with lowercase g, which is 2 times f minus g. So like if you knew the function f of x, you put an x in, you get a y, you multiply by 2, then you subtract whatever g is at that same value. Okay? And then I want to find the following derivative, and all I have to go on is the information here in this graph. I don't have formulas for the functions lowercase f and lowercase g. I just have this graph, but it's really all the same information because whether you have a formula for a function or the graph, so long as you can identify what the points are, you get the same information. Okay, I know we deal with formulas differently than graphs, but in the end, it's supposed to be all the same information. So here's what I would do to find g prime at 1. So first of all, since all I have to go on is the information in this picture, I think the way that I should interpret the derivative, g prime means derivative, the derivative of capital G right there. I'll need to interpret the derivative as the slope of the curve or the slope of the graph. Okay, so that's my first premise. My second premise is that, well, if you're telling me that capital G is 2f minus g, then the derivative, by the rules for derivatives, the rules whether you have a formula or a graph or however the function is given to you, the rules tell me that capital G prime is 2f prime minus g prime, meaning that this coefficient of 2 does not affect how I calculate the derivative. I just carry it into the answer, and same thing with the subtraction. Okay? All right, now putting these two things together, g prime at 1 means this. It says 2 times the slope of the curve f at x is equal to 1. And then for context, the curve f is given in blue. Okay? Minus the slope of g at x equals 1. And then for context, in red here is g. Okay? All right, so now can I find the slope of each of these at x is equal to 1? Well, I notice on my scale here, 1 is right here. Okay? And that means I guess I'm just looking at these portions of the graphs. These graphs are just two lines that meet at a common point, all right? But if I want the slope at 1, this point, I could find the slope anywhere along here. It's the same everywhere because it's straight. Same thing with g. If I want the slope of g at x is equal to 1, which is right here, I can find the slope anywhere, okay? So all I've got to do is find some points that are clearly enough labeled, like this one right here, it's like right there at the cross on the grid, and I can tell that that's 1 and 3 and so on. But I just have to find 2 points and calculate the rise and the run, and slopes rise over run. Okay, so for the slope of f at x equals 1, I chose this point and this point just because those were the two that were obvious to me. You might choose different ones, but so long as you're clear on what it is, it's fine. Okay, so I chose this one and this one, and the rise is -3 and the run is 1. So I don't do anything exotic there. I'm just looking at rise and run. Slope is rise over run. So it's 2 times -3 over 1. That's the slope of f at x equals 1. It turns out it's -3. Okay, and then for g at that same point, well, I can look anywhere along here at any points I want, so long as I'm clear what they are, and I calculate rise over run. That's the slope of g. So I chose this point and this point. Again, you can choose slightly different points as long as you are sure what they are. And from here to here, the rise is 1 and the run is 1. So the slope of g at x equals 1 is 1 over 1. And then what do I get here? 2 times -3 minus 1, that's -6 minus 1, that's -7. And that's how they get that -7 there. Okay, so I can't use formulas for the derivative because I don't have formulas for these functions. But if I know that the derivative is just the slope of the curve, and then I can look at that graph and I can tell you the slopes being just rise over run, then even though it seems that there wasn't much information to start with here, it's entirely possible to solve.